Bucket tests are often used to monitor the sediment content of water during well development. Sometimes these tests are also carried out to see whether unwanted sediment is coming into a borehole through damaged casings. By measuring the sediment content of discharge water at regular intervals during well development, you can observe the expected decreasing sediment content, indicating when the water is suitably clear and borehole development has been completed successfully. Bucket tests are great because they're easy to carry out and the only equipment required is a bucket. However, they don't give precise measurements and are only really suitable for use in the field. They should also not be confused with turbidity measurements, which are a different thing.
Collecting a sample in a bucket and waiting to see how much sediment settles at the bottom. I've taken here a 20-litre sample of the water we're discharging, and we want to see how much sediment is in there. So obviously the small particles that may be in the water are in suspension, and the larger the particle, the quicker it will settle. The smaller the particle, the longer it will stay in suspension. So what we typically do here to work out roughly how much we have is that we'll circulate the water a bit to create a sort of whirlpool effect that should bring all the sediment into the middle, and we'll give it 5 minutes to settle out at the bottom of the bucket, and then we can take our measurement. So usually it's fine if I do this, put my hand in, start to make the water go round and round and round, and if we leave it for 5 minutes, we'll wait for all of the fine particles to settle out, and we'll see how much sediment we have there. We've left our bucket of water for 5 minutes, and most of the sediment that was in suspension has now settled at the bottom of the bucket in a small circle. So because we did our whirlpool motion, all the sediment settled in the middle, and it makes it very easy for us to see exactly how much there is.
We are looking for less than 1 centimetre cubed in 1 metre cubed of water, which corresponds approximately to a knife tip of sediment in a 10-litre bucket.
So what we have here is we've actually got a circle of sediment in the bottom of the bucket that's about 2 or 3 centimetres in diameter. So that's indicating that we have too much sediment in the water, and this could potentially cause problems with pumping equipment, and pipes will be exposed to increased abrasion, which could lead to premature breakdown of the pumping equipment.
Carry out one measurement every 15 minutes during development and plot the results against the discharge rate. When the target value of 1 centimetre diameter of sediment is seen in the bucket and the flow rate is stable, then the well development is finished, but only if it's been ongoing for at least 2 hours. For precise measurements of sediment content, an Imhoff cone is used, but in many cases the bucket test is sufficient and far better than nothing.